All right, here's a second example on graphing a quadratic inequality in standard form. So we've done one already. So I'm going to go ahead and just change this to an equation. And then we're going to find all the important parts. So we have A, B, and C. This is going to be concave up because that A number is positive. Because our A right here is greater than 0. Our A is also equal to 1, so it's going to be the same as its parent. So our parabola is going to look something like this. It's going to open up, and it's going to have a minimum for its vertex. Now we're going to go ahead and find the axis of symmetry equation using our equation x equals negative b over 2a. So we substitute our b and a in. And then we simplify that. 7 divided by 2 is 3.5. So our axis of symmetry is at 3.5. I'm going to move on to finding the vertex. So to find the vertex, the x-coordinate is going to be 3.5 because it runs along the axis of symmetry, and we want to find the y-coordinate. So we're going to go ahead and evaluate the function for 3.5. And then we simplify it, and we get negative 2.25. So the vertex has now been found. Then we want to find the y-intercept, so we evaluate the function for 0. And we simplify it, so we get the order pair 0, 10. So I'm going to stop there for a moment, and now start to graph those important pieces. So I had my axis of symmetry at 3.5. The vertex at over 3.5 down 2.25, so about there. Then I have that y-intercept up at 0, 10. So I'm going to create a reflection point, the same distance of 3.5 to the right, so at 7. So there's 3 points there. And then we're going to move on to finding the x-intercepts. So to find the x-intercepts, we're trying to find those critical points. We're trying to find out when we set the function equal to 0. So we are going to, this time, just go right to the diamond. So what are the factors of 10 that add to negative 7? And that's negative 5 and negative 2. So in factored form, our two binomials are x minus 5 quantity, x minus 2 quantity. Then we would do our zero product property, set the factor equal to 0, and solve for x. So our first x-intercept is 5, 0. Set our second factor equal to 0. Solve for x. Our second x-intercept is at 2, 0. So when we create our number line, those will be our critical points, 2 and 5. Now I'm going to go ahead and graph those points. And now we have our 5 points. So we have y greater than or equal to x squared minus 7x plus 10. Notice this time now we have a line underneath that inequality. So it is going to be a solid parabola. And we want to find out, where should we shade our parabola, inside or outside the parabola. So we have to check it with our critical points. So our inequality, 0 greater than or equal to x squared minus 7x plus 10. So we're going to test to the left of 2, between 2 and 5, and then to the right of 5. So you get to kind of choose which numbers you want. So I'm going to choose something to the left of 2. So I'm going to choose the number 0. Then I'm going to choose a number between 2 and 5. So I'm just going to choose the number 3. And then lastly, I'm going to choose something to the right of 5. So I'm going to choose the number 6. We're trying to find out, when is it true and when is it false. And we shade the region when it's true. So let's go ahead and test now. X equals 0. We sub it in for x. So 0 squared minus 7 times 0 plus 10. And when we're done, we read the inequality. Is 0 greater than or equal to 10? No, that is false. So in that entire region, less than 2, it's false. So we put a negative. Then we're going to test the number 3. That any number between greater than 2 and less than 5. So I'm choosing 3. And we sub it into the inequality. So 3 squared minus 7 times 3 plus 10. And then we simplify it. And then we read the inequality. Is 0 greater than or equal to negative 2? Yes, that's true. So between the interval from 2 to 5, it is a true. So we put a plus. Last one. X is 6. Sub it into the inequality. And then simplify it. Is 0 greater than or equal to 4? No, that is false. So we put a negative there. So the interval where the solution is true is between 2 and 5. So that's the area we will shade. So we shade between the critical points from 2 to 5. Our solution, we write it as an interval from 2 to 5.